Solutions to Leaving Cert Examination 2023, Maths Paper 2, Ordinary Level. Question 1a, Part 1. Work out the slope of the line AB. Slope formula is y2 minus y1 over x2 minus x1. Write down your two coordinates and label them x1, y1, x2, y2. Filling in my formula now, I have my y2, which is 8, subtract my y1, divided by my x2, subtract my x1. So that's giving me 6 over negative 3, which is giving me a slope, or m for slope, of minus 2. Part 2, work out the distance from A to B. Again, from my log tables, my formula for distance is x2 minus x1 all to be squared, plus y2 minus y1 all to be squared in my square root. Write down my two formulas again, or my two coordinates again, but I have them from part 1, so I'll just use them from there. So it's going to be the square root of my x2, which is 1, subtract my x1, which is 4, squared, plus y2 minus y1, all to be squared. So that's giving me a distance of 1 minus 4, which is negative 3 to be squared, plus 6 to be squared. That's giving me negative 3 squared, which is 9, plus 6 squared, which is 36, which is the square root of 45, which simplifies to 3 root 5, or 6.7. The question didn't say to square root or decimal, so either solution is fine. Part B, find the equation of the line through minus 2, 7 with a slope of 1/3. Just be careful there, give your answer in that form, so it has to be x, y, number equals to 0. From the log tables, equation of a line is y minus y1 equals m times x minus x1. Label your coordinate x1, y1, and your 1/3 is your slope, or your m. Filling in your formula now, I have y minus y1, so y minus 7 equals my m, which is 1/3, times x minus minus 2. To deal with a fraction, you multiply across by the denominator, so just a shortcut here is multiply the 3 to the left and the 1 to the right. So that's going to give me 3y minus 21 equals 1 by x is 1x, and 1 by positive 2, because the two negatives make a plus. I'm going to move everything to one side, so I'm going to keep the 1x, I'm going to keep the plus 2, I'm going to subtract the 3y from both sides and add the 21 to both sides, and that's going to equal to nothing. Rearranging that, I have 1x minus 3y, 2 plus 21 is 23, and I'm just going to put the 0 at the end. So 1x minus 3y plus 22. Part C, the point 42 is shown in each of the two coordinate diagrams below. Part 1, draw the line segment through the point 42 with a slope of 2 on the coordinate graph in the range minus 2 to 6. Okay, so it has a slope of 2. So try and think of if I have a slope equal to 2, that means I have m equals to 2, m meaning slope. Another way of writing slope is you can use your coordinates, y2 minus y1 over x2 minus x1. It makes it a little bit more difficult, but I could use rise over run. So I'm basically just looking for a fraction that makes 2. So my rise over run could be 4 over 2, 8 over 4, or just simply 2 over 1. And remember what this means here. This is my rise, and this must be my run. So if I'm drawing my line now, it would have to be running 1. So I'd need to come across one box, and I'd need to rise 2. So that could be a possible location for my coordinate. Then I get my ruler, and I draw the line between those 2 points. And remember what the question says here, though. It's saying it's between minus 2 and positive 6. So I'd need to go all the way. So what that means here is from here to here. So that would be part 1 done. Scrolling down now to part 2. It says draw the line segment through the point 42 with a slope of minus 2/3. Let's tackle it the same way again here. So I have a slope of minus 2/3. So that's the same as m. We'll go with rise over run again. So in other words, I have 2/3 negative. I have a rise of 2 and a run of 3. Now remember that this graph is going down. So what I'd have to do here is, it doesn't matter what way you run. You can go this way, 3, or you can go this way, 3. It's up to you entirely. I'm just going to go back for a change. So I'm going to go back 3, or my run. That's bringing me to here. And I'm going to go up 2, because that's my rise. So I'm going to put a point here. Now you should notice that the question gave us negative 2 over 3, so that means it's going to be a negative slope, so my line should be going down, which it is. When I flip my ruler, my line is going this way. So if I draw the line, it's looking like that. Now it says x is between -1 and 7, so technically I should only be going from -1 to 7, which would be that line there. Again, you can pick any points on those coordinate graphs. I've just gone with the 2 I've used, but as I said, there are many points you can pick. Question 2a, part 1. Write down the center and the radius of the circle S. So this is the center 0, 0, because I'm not subtracting a h or a k, and the r squared is 25, so r squared is 25. Or is equal to the square root of 25, so my radius would have been 5. Show that the point 3 minus 4 is on the circle, so if it's on the circle I can sub it in and it should satisfy it. So I'm taking my equation of the circle x squared plus y squared equals 25. I'm going to sub in 3 for x minus 4 for y. And I should make 25. So let's see, if I sub in 3 and minus 4, 3 squared is 9. Minus 4 by minus 4 is positive 16. Make sure you're using brackets on your calculator. And that's 25 is equal to 25. So since equals, so 3 dots meaning therefore. So since equal, it is on circle. Okay, scrolling down to part 3 now. It's saying write down the coordinates of 2 other points that are also on the circle S. Now remember, if we go back up to the first part of this question, it told us, or we figured out, that the center was 0, 0. Very rough sketch there, but we also found that the radius was 5. So think about it this way, my radius of 5 can go up, down, right, or left. And if I create the circle now between those 4 points where it'll cross the x and y axis, it would look something like that. Now, very rough. Again, this is just to visualize it. So the 4 points, I know the question said just write down 2 other points that are on the circle, but I could use this one here, which would be 5, 0. I could use this one here, which would be 0, 5. I could use this one, which is negative 5, 0. And I could use this one down the bottom on the y-axis, which would be 0, minus 5. So there's 4 coordinates. It asked for any 2. Part B, find the point of intersection between a different circle K and the line L. So this is simultaneous equations where you're subbing in the line into the circle. So basically what we're going to do is we're going to take the line L and we're going to manipulate it. So what I mean by that is you can have it to be y equals 2 or x is equal to. So easier to stick with the y, move over the 5x becomes a negative and the 13 to become a positive. Change the signs because I want positive y, so that becomes positive y is equal to positive 5x, negative 13. So this part now that we found is very important. So I've got my equation of the line in terms of x's and y. So y is equal to 5x minus 13. I'm now going to sub that in to my equation of the circle where I have y. So see here, I'm just going to substitute 5x minus 13 in for y. And the reason for that is you'll build an equation in terms of just one variable, x. So if I sub that in now, I have x squared plus y squared, which is now going to change to 5x minus 13. I need to multiply out that bracket now. So if I do a little bit of algebra now, it's x squared plus 5x minus 13 by 5x minus 13, because that's what a square means. And opening out the bracket, it's going to be first term by second bracket, second term by second bracket. And don't forget, that is all equal to 13. So tidying that up, I get x squared. Multiplying in the 5x by the 5x, I get plus 25x squared. Multiplying the 5 by the minus 13 makes minus 65x. Minus 13 by 5x again, minus 65x. And minus 13 by minus 13 makes positive 169 equals to 13. I'm now going to just move that 13 over, or subtract it from both sides, and tidy up. So I have now a x squared and a 25x squared, which is making 26x squared. I have the minus 65x, which is making minus 130x. And then I have the 169 subtract the 13, which makes it plus 156 equals to 0. I need to solve this quadratic equation now, so you can go to your minus b formula or your two brackets. I think it might be easier though to find a common factor first. So I'm going to divide it by 13 because 13 goes into each of the numbers. So 13 into 26 makes 2x squared. 13 into 130 makes minus 10x. 13 into 156 makes 12. Now you don't need to divide by the 13, it's just making it a bit easier for me. Like I said, you can go with your guide number, your minus b formula, or your two brackets. Actually, what I could do there is I could also divide by 2. I should have divided by 26. So I'm just going to divide by 2 now, which is going to make 1x squared minus 5x plus 6 equals to 0. Factorize that. And I'm getting factors of 6 will be multiples. 2 by 3 equals to 0. So that means that x is equal to 2 and x is equal to 3. Now the question, if you go back up to it, it says find the points of intersection. So what we're trying to do here is you're trying to find the points of intersection of a circle and a line. So you have two coordinates. I've got the x's, they are 2 and 3. I now need to find the corresponding y's. So what I do now is I come back to the top, I take this part here, the part I manipulated, because this will help me find my y. All I do now is sub in my two values for x, so I'm doing it out twice basically. I'm going to sub in the 2 and I'm going to sub in the 3. So let x equals to 2 and then I'm going to let x is equal to 3. So I have 5 times 2 minus 13 and 5 times 3 minus 13. So subbing in my 2 and my 3, that's giving me 10 subtract 13, which is giving me negative 3. So that coordinate is 2 for x minus 3 for y. And the second one is 15 subtract 13, which is 2. So the coordinates there is 3, 2. So find the points of intersection between the circle K and the line L. Well, they're my 2 points there. 2 minus 3 and 3, 2. Question 3a, part 1. In how many ways can the letters of the word camogie be arranged? So there are 7 letters in camogie. 3, 4, 5, 6, 7. I can put any one of the letters first, so that means there are 7 possibilities for that first letter. If I use one of the letters, so assume I use the I, that leaves 6, and so on. So 6, 5, 4, 3, 2, 1. Multiplying those together, which is the same as 7 factorial if you prefer using the button on your calculator, so 5040. Part 2, in how many ways? In how many of the arrangements in part 1 start with M and end in a vowel? So again, I have 7 letters. Multiplication for and. Starts with an M. I only have one M in the word camogie, so I must put a 1 here. It has to be the M. It ends in a vowel. The vowels are A, E, I, and U. A, E, I, and O, I should say. So there are 4 vowels, so I can put 4 letters in as the last letter. So that means that I've used up 2 spaces of the 5, 2 spaces of the 7. 7 letters subtracted 2 I've used leaves 5 letters left over. So that means I can have 5 for my third, 4, 3, 2, 1. Because remember, that last letter, I can only put 1 in there. I know I have a 4 here, but that means there's 4 possible letters that could go in there, but I can only put 1 of them there each time. And part 3, how many arrangements of 3 different letters can be made from the letters in the word camogie? So I'm only looking for 3 letter words. I have 7 letters in camogie. That means I can have 7 for the first letter. Let's assume we use one of them up. That means I can have 6 and then 5. And I didn't write in my answers up above, actually. So the answer to part 2 was 480. And the answer now to part 3 is 7 by 6 by 5, which is 210. B. 3 scatter plots are shown below. They are labelled A, B, C. Each scatter plot has the same axis and scale. The correlation coefficient for each scatter plot was calculated. The results were 0.95, 0.6, negative 0.95. Part 1, write each of the letters A, B, and C to correspond. So the first one there is 0.95. Now that's a positive 0.95, so it has to be either B or C, because A is a negative, it's going down. It's a strong positive, so I would be going for a line through the points here. So that means it would be B. I then need 0.6, which again is a positive value. I've used B, so I can't include that one now, that's gone. So my only remaining positive graph is C. And the reason why A then must be negative 0.95 is because it's going down from left to right, and they are fairly grouped around that line of best fit. Part 2, for scatter plot B, explain why the value you picked is correct. So I picked C, isn't it? Or no, sorry, I picked B as 0.95. Remember your correlation coefficient scale, I'm just going shorthands there, must always be between -1 to 0 to +1. So it must fall between -1 and +1. So that means where, actually we can state all this, where 1 is perfectly strong, a correlation coefficient, and 0 would be no relationship. There's no relationship between the two variables. So in my answer here for B, I can see that B has a strong positive correlation coefficient, i.e. I'm just going to say the dots are increasing positively. And close, or grouped we'll say, to the line of best fit. That's the red line that I've drawn. Question 4a, part 1. Find the probability that he scores his first 3 throws. Probability of scoring is 0.7. So we're looking for score and score and score. And in probability, meaning to multiply, and the probability of scoring is 0.7. So 0.7 by 0.7 by 0.7 is 0.343. Now you can put that as decimal, fraction, or percentage for the marking scheme. Part 2, find the probability that he scores exactly 2 of his first 3. So there's different combinations there we could have. We could have score, score, miss. We could have score, miss, score. Or we could have a miss first, followed by a score and a score. So we need to do out all 3, and it's this one, or this one, or this one, or in probability, meaning to add. So score, score, miss, 0.7 by 0.7 by 0.3, which makes 0.147. Score, miss, which would be 0.3, taking it away from 1. All probabilities must add up to 1, so 0.7 plus 0.3 is 1. And the third one, 0.3 by 0.7 by 0.7, again is 0.147. Now you could just go 0.147 by 3 or just add them. So that's giving me 0.441. Again, fractions, percentages are fine. And the final part to part A is give one reason why scoring his free throws might not be independent. Independent means they have no impact on each other. So in this question, it's saying they're not independent. So it means that each throw does impact on the next throw. So one explanation could be, if he were to score the first, it would build his confidence to score the next. And conversely, If he missed the first throw, it may knock his confidence in future, so hence reducing the probability of scoring the second. Question 4b. Work out Rowan's mean number of points per game based on the values in the table. Give your answer correct to 2 decimal points. So this is the mean from a distribution table. So what we're going to do here is we're going to multiply the number of points by the number of games in each case. So 0 by 4, then I add on the 6 by 5. So again, what I'm doing here is I'm multiplying the number of points by the number of goals. So that's giving me the total amount. So 8 by 4 plus 10 by 2 plus 12 by 3 plus 16 by 1. I divided that by the total number of games, which is 4 plus 5 plus 4 plus 2 plus 3 plus 1. Tidying up the top line, 0 by 4 is 0, 6 by 5, 30 plus 32 plus 20 plus 36, and 16 by 1 is 16, all over the addition, which gets me 19. The top line will add up to 134 over 19, and dividing 19 into 134 to 2 decimal points is 7.05 points per game. Question 5. The diagram below, not to scale, shows a square with sides of length 12 centimeters. The circle C is inside the square and touches the 4 sides of the square. The circle K is outside the square and goes through the 4 corners of the square. Part A, find the length of the radius of circle C. So we're looking now at circle C, which is this inner circle. And in order to get the radius of that circle, try and think of, remember that the full square is 12. So that means that this distance through the center of C is 12. So that means it's broken into 2 parts, or 2 radius, which is 6 and 6. If we were to go the other way, I would also have a 6 and a 6 here. Now what it's asking us to do is get the radius of circle C. So you can use any one of those answers or any of those variations of solving the question to get your answer of 6. So basically it's just 12 divided by 2, which is 6. Part B, work out the area of circle C. Give your answer to 2 decimals. So area of circle from our log tables is pi r squared. Keeping the pi button on our calculator, it's going to be pi multiplied by r, which is 6 squared, which is 36 pi. As I said, it wants it to a decimal place of 2, so that's an area of 113.097 to 2 decimals. That's giving me an area of 113.10 centimeters squared. Don't forget to put in the centimeter squared. C, work out the percentage of the area of the square that is taken up by circle C. So we have the area of circle C, we just need to get the area of the square now. So the area of a square is length by width, and the area of that square, if you scroll back up, the length is 12 and the width is also 12. So that's giving me an area of 144 cm squared. Now I need to get the percentage of the circle over the area of the square. So from part B, my answer was 113.10 over my area of the square, which is 144, times by 100 over 1, and that'll get me my percentage, which is giving me a percentage of 78.5%, and it wants it to the nearest percentage, so it's 79%. Part D, show that the radius of the circle K is 8.49. So let's scroll back up to the picture here. So radius of K, 8.49. So what I'm going to do here is, so we're looking at circle K, radius is this line here in green. Now what I'm going to do is I'm going to break it into a triangle, because we know that this distance is 6 because it's half the 12, and this distance here is also 6. So what I'm going to do is I'm going to use Pythagoras theorem here to get the hypotenuse of that triangle. So I've just sketched it out, 6, 6 and r for radius. Pythagoras theorem is c squared is equal to a squared plus b squared, or any variation of that. Just remember that the c is always the side across from the 90. So that must be my radius. So I have it as r squared equals 6 squared plus 6 squared, which is giving me r squared is 36 plus 36. R squared is equal to 72. Square root of both sides, so the square root of 72 is 6 root 2, or as a decimal, 8.49 centimeters. And part E, work out the circumference of circle K, correct to 2 decimal points. So from our log tables, circumference is given as 2 pi r. Filling in our formula now, it's 2 multiplied by pi, keep it as the button rather than 3.14, multiplied by the radius, 8.49. Multiplying those on my calculator, I get a circumference of 53.34 cm to 2 decimal points. Question 6. Construct the parallelogram ABCD in the space below. The point A is given as part of the line AB. So for your construction, make sure and use your compass, your ruler, your protractor, and make sure and show all of your workings. B, the diagram below shows another parallelogram not to scale. Use the information in the diagram to work out the value of x and the value of y. So let's start with x. In a parallelogram, we know that opposite angles are equal. So these two angles must be equal. So they'll help us to solve for x. So that means that 2x minus 30 is equal to 100. We add 30 to both sides, or move over to minus 30, so that's 2x is equal to 130. Divide both sides by 2, x is equal to 65. So 65 degrees for x. Now we are going to look at the value for y. Well, remember in a parallelogram, all the 4 angles must add up to 360 degrees. I have 2 of the angles, this one and this one, being 100 each, so 100 plus 100 gets me 200. Remember what I said, all 4 must add to 360, so let's remove those 2, leaves 160. So that means, if I just clear up my diagram here, that this angle and this angle must add to 160. So that means that each of them is 80 degrees, so if I divide by 2. So this angle must be 80 degrees. So I'm going to go x plus 3y equals 80. I know the value of x at 65, so I can sub that in. So 65 plus 3y equals 80. So that's 3y is equal to 80 minus 65. I'm running out of space here. So that's 3y is equal to 15. Divide both sides by 3 gets me y is equal to 5 degrees. And the final part, C, state whether the following statement is true or false, justify your answer. Every square is a parallelogram. I'm going to say true. So the first part of my justification is a square has opposite sides equal in length, as does a parallelogram. So that means the square is linking to my parallelogram. I can also say opposite angles in a square are equal, as are those in a parallelogram. The only difference there is that in a square, it just happens that the angles are all 90 degrees, and that's why we call it a square. It's a particular type of parallelogram. So opposite angles are the same, opposite sides are the same. A square is just a particular type of parallelogram, that all sides are the same. Section B, question 7. Olga is a cyclist. She is measuring how long and how steep different roads are. Part A, the diagram below shows roads A, B. AC is horizontal, the BC is vertical. The diagram is not to scale. The gradient of road AB is as follows. Gradient is just another word for slope. So looking at part 1, find the gradient of road AB, where BC is 24, AC is 135. Give your answer to correct to the nearest percent. So we're basically going to use the formula they've given us here. BC over AC. You can hopefully spot that that's basically rise over run. So B to C is rise and A to C is run. So it's basically slope, really, is what it's asking us to do here. But using the formula they've given us, BC over AC, filling that in, I have 24 over AC, which is 135. The question wants it as a percentage, so I need to times that by 100 over 1, and that's giving me 17.78%. Question wants it to the nearest percentage, which is 18%. Part 2, find AC when BC is 16 and the gradient to the road is 12%. So I'm going to use my formula here again. So remember what it is. It's another word for slope is gradient or rise over run. So they've given it as BC over AC. Now, if I fill that in, I have BC, which is 16, over AC. I don't have it as AC anymore. It's now going to be, sorry, I do. It's AC, I should say. And the gradient of the road AB is 12%. So if I multiply that by 100 over 1, I should get 12%. That's literally what it's telling us. So I have 16 over AC is equal to, well, divide my 12 by 100. As a decimal, 12% is 0.12. If I cross multiply now to get rid of the fractions, that's giving me 16 is equal to 0.12 AC. So that means that if I divide both sides by 0.12, I'll figure out what AC is. So AC is equal to 133.33. Question again said to the nearest meter. So 133 meters is equal to AC. Part 3, use theorem of Pythagoras to find AC when BC is 27, AB is 105. Give your answer to the nearest whole number. So if I just draw out the shape here again, so if I sketch it, I have my A, my B, and my C. They're telling me that BC is 27 and AB is 105. They want me to find the length from A to C, this length here. So Pythagoras' theorem is C squared is equal to A squared plus B squared, or any variation that you use. And filling in my C, that's the side across from the 90. So that's my 105. Equals my A and my B, they're the other two sides. Doesn't matter which is which. So 27 squared plus AC squared. So 105 by 105 is 11025 equals 27 by 27 is 729 is equal to AC squared. Sorry, it should be plus here. If I subtract 729 from both sides, that's 11025 minus 729 is equal to AC all to be squared, which is 10296 is equal to AC squared. If I get the square root of both sides, that'll solve for AC. So AC is equal to 6 root 286. So hit the SD button there will get you 101.47. Question wants it to the nearest whole number. So therefore AC is equal to 101 meters. Find the size of angle BAC when the gradient of the road is 9%. So let's come back down here now and just sketch this out very quickly. We have the A, C, and B, and they're looking for angle BAC, which is in here. Let's just call that theta. You can call it A if you want. So we would label our picture using our sine, cos, and tan. So this would be opposite, hypotenuse across 90, and then the adjacent. And again, remember what's going on here. We keep saying in each question, it's looking at rise over run. Now, rise over run in this question would be rise, which is opposite, and my run would be A to C, which would be my adjacent. So that's going to be the same as opposite over adjacent. And they're telling me that that is equal to 9%, which is opposite over adjacent, which is equal to 0.09. Now, you can hopefully spot if you remember your rules. It's silly old Harry caught a herring trawling off America. Now I'm using the last one here, opposite and adjacent. So I have tan of my angle is equal to 0.09 because opposite over adjacent is the ratio for tan, isn't it? Tan angle is equal to opposite over adjacent. And that's what I'm using here. So I'm just substituting tan theta in for opposite over adjacent. And hopefully now you can spot that rise over run is the same as tan theta. So tan of an angle is basically getting you the slope of that line. To get theta on its own, we do the inverse of tan because it has to be moved over. So it's tan inverse of 0.09, which is giving me an angle of 5.14 degrees. The question wants it to the nearest degree, so 5 degrees. Part B, work out the distance OR, give your answer correct to the nearest meter. So first of all, I'm going to find the size of the third angle here. So I'm going to take the full amount of angle, 180, subtract the 87 and the 88. And that will give me 180 minus 175, which gives me 5 degrees. So that missing angle here is 5 degrees. I'm then going to go to my log tables and use the sine rule to solve for the side OR. So that's A over sine A, B over sine B. Coming up to the picture, the side I need is OR. This side here. So I'm going to call that my A. And the side opposite it, or the angle opposite, is going to be my angle A. Then I'm going to take a second side, this one here, the 20 meters, and the angle opposite it is 5 degrees. So filling that into my sine rule, I have A, which is my OR, the side I need, over sine of A, which is sine of 87, which is equal to 20 over sine of 5. And if I cross multiply, it gives me OR times sine of 5 equals 20 times sine of 87. You can turn them into decimals if you want. I'm going to stick in their original form. So that means OR is equal to 20 times sine of 87 divided by sine of 5 degrees. And when I work that out, I get the length of OR to be 229.16. And the question wants it to the nearest meter, so 229 meters. Part C, work out the size of the angle marked with the X in the triangle. Give your answer in degrees, correct to 1 decimal point. So I'm going to use my cosine rule from my log tables, and my cosine rule is given as a squared equals b squared plus c squared minus 2bc cos a. If I label my picture now, the angle X is the angle I need. So that's going to be the A in my formula. So the side across from it is the side A, the small a. And the B and the C can be the other two sides. So I'm going to go B for 700, C for 800. Filling in my formula now, I get 550 to be squared is equal to B squared, which is 700, plus 800 squared minus 2 times B times C. I have them the wrong way around, but it shouldn't make a difference, but let's do it correct. 700 times 800 times cos of the angle X. Tidying that up, 550 squared is giving me 302. 500 is equal to 490000, so 490,000 plus 640,000 minus 2 times 700 times 800 is 112 and 4 zeros. So these are massive numbers here, but hopefully it'll tidy up in a second. What I'm going to do then is I'm going to add these two together and move them over the equals. So that is 302,500 minus 113,000 equals minus 112, 4 zeros, cos X. If I subtract the left-hand side, that's giving me minus 827,500. is equal to minus 1,120,000 times cos of x. To get cos of x, we divide across, so that's giving us cos of x is equal to minus 827,500 all over minus 1,120 followed by another 3 zeros. When I work that out on my calculator, that simplifies to a positive 331 over 448 is equal to cos of x. And to get x on its own, we find the cos inverse of the fraction. So that's giving us x is equal to cos inverse of 331,448. Putting that on my calculator, I get 42.367 degrees, and it wants it to one decimal place of 42.4 degrees. Now, in that question, you can take a lot of shortcuts there with the powers and tidying up and that. I've just shown every step along the way. Question 8. A. The instruction manual recommends that the pool should be fitted to a maximum depth of 0.75 meters. Work out the volume of water in the pool when it's filled to this maximum depth. Give your answer in meters cubed and correct it 2 decimal places. So you can see there that the shape of the pool is in a cylindrical shape, so it's a cylinder. So from my log tables, the volume of a cylinder is pi r squared h. And to get the volume, I keep the pi button on my calculator, multiply it by my radius squared. The radius is given, well, they tell us here in the question that the diameter is 2.4 meters. So if I divide that by 2, I get my radius of 1.2 meters. So filling that into my formula now, it's 1.2, and I'm timesing that by the height, the maximum depth of water in the pool, which is given as 0.75 meters. When I work that out on my calculator, I get a volume of 3.39 meters cubed. B part 1, show that the total volume of the 3 pool seats is 0.375 meters cubed. It's a cube in shape, so volume of a cube is given as length by width by height. And filling in my dimensions, it tells us here that, well, it's a cube of side length 0.5, so that means the length, the width and the height are all the same. So I have 0.5 by 0.5 by 0.5, and the volume of one seat is 0.125 meters cubed. There are 3 of them, so I times that by 3, so I get 0.375 meters cubed. B part 2, find the amount by which the water level in the pool rises. Give your answer in meters corrected 2 decimal places. So what that means is the volume of the 3 seats is going to equal the volume of the displaced water within the cylindrical swimming pool. So my pool has a radius of 1.2 meters. So I'm going to use basically the volume of the cylinder formula basically to figure out by how much did the water rise when I put the 3 seats into it. So volume of a cylinder is equal to pi r squared h from my log tables. The volume of the cylinder, or the extra displaced water, is the volume of the 3 seats, which is found in part B, so that's 0.375. I'm letting that equal to pi r squared h. Now I know the radius, it's 1.2 meters, and the height is what I'm trying to find. That's what the question wants us to get. Find the amount by which the water level in the pool rises. So that's the height, in other words. Tidying up the right hand side, I get 0.375 is equal to 1.44 pi h. To solve for h, divide across both sides by 1.44 h. And that is giving me a height of 0.083. Question wants it to 2 decimals, so therefore h is equal to 0.08 meters. Part C1. Show that the slant height of the cone marked L in the diagram above is 1.53 meters corrected to decimal places. So they basically want you to show that that line in red is 1.53. Now what I'm going to do here is I'm going to make a triangle out of that. And it is a right angle triangle because it's a right circular cone. So this is a 90 degree here. So I'm going to use my Pythagoras theorem, which is given as c squared equals a squared plus b squared, or whatever letters you're used to using. The c is the L, the hypotenuse. The a and the b are the other two sides. Doesn't matter which is a and b. Filling that into my formula now, my c is L squared is equal to 0.8 squared plus 1.3 squared. Tidying up the left hand side, it's 0.64 plus 1.69, which is giving me L squared is equal to 2.33. Get the square root of both sides to get L on its own. So L is equal to 1.53 as the question asked. Part 2. Work out the curved surface area of the conical cover. Give your answer to 2 decimals. So again, log tables here for surface area of the curved part of a cone, which is pi or L. So A is equal to pi, button on my calculator, multiplied by the radius, which is 1.3 given in the diagram above, multiplied by 1.53, which is the L we found in part 1. And when I type that on my calculator, I get 6.2486. Question wanted to 2 decimals, so 6.25 meters squared. Part 3. The diagram below shows the net of the conical cover, not to scale. It is a sector of a circle of radius x. So that's important here. So they're telling us the radius is x. Write down the value of x and work out the size of the angle A. Now the size of the angle, the length x is coming from our previous part, C part 1, where they tell us the radius is, I should say the length of the slanted side is the length x, which is the 1.53. So our x is 1.53. I'll just show you on a different slide here what that looks like. So take a look here at the shape on the left hand side here, and in particular the L, this slanted side here on the cone. And as I open out the cone, the net, keep an eye on the L, the slanted side. When I open up the shape now, that slanted side has now become the radius length on that sector. So look at it here, that L is the radius length of the new sector, but when it's closed, that L is the slanted height of the cone. The next part to the question wants us to find the size of the angle X. The angle A, I should say. The angle as part of a sector coming from my log tables is given as, I could use the area formula I could use here, which includes the angle, which is theta over 360 multiplied by pi r squared. Now, we know that the area of that curved section, this section here, if I look back on part 2 to the question, we found the area of that curved part to be 6.25. So I'm going to fill 6.25 in for my A. Let that equal to my angle, which is the A in the question, over 360 multiplied by pi r squared. Now my radius here is 1.53 to the power of 2. Tidying that up a little bit, I get 6.25 is equal to A over 360 times 2.3409 pi. If I cross multiply then, or actually before I cross multiply, I might just put this over 1 and multiply these two fractions, so top by top, bottom by bottom. So I get 6.25 equals 2.3409 pi A over 1 multiplied by 360. Again, I'm going to make a fraction on the left here, and I'm going to cross multiply, which is giving me 6.25 multiplied by 360, which is 2250, is equal to 1 multiplied by the top of that second fraction. And that's giving me 2.3409 pi A. And in order to get A in its own, I'm going to divide both sides by the 2.3409 pi. and again to the left. And that is giving me an angle size of 305.95. The question wants it to the nearest degree, so that's an angle A of 306 degrees. Question 9a part 1, work out the maximum number of students in this sample who, on average, could have read more than 100 minutes per day. So these 10 students read more than 100 minutes. They read 150 to 180, as did these 18. And we're also going to assume that these 59 read more than 100 minutes. They read between 90 and 120, but the question said what's the maximum number of students who could have read greater than 100. So we're going to assume that those 59 are included as well. So we're going to assume like they read 101 minutes, for instance. They could have read less, but the question asked for the maximum. So we're going to assume they did read above 100 minutes. So that's bringing us to 87 students in total. Part 2, estimate the mean time spent reading by those 200 students as accurately as possible. The mean is the number which is found in the middle. So we have 200 students. So if I take my 200 students and find the middle student, I divide by 100. So we're looking for the 100 student, roughly around that 100 students mark to get to the median. So if we go up to our table again, these 16, don't forget this is in order from 0 to 188 or 180 minutes. So the first 16 are accounted for. So we're not at the middle student yet. We go to the next 35. So it's the next 35. So in total, that is 16 plus 35, which is 51 students. So the 51st student is accounted for. So we're not there at the 100 yet. Bring in the next 62. So that's bringing me to 51st plus 62, which is bringing me to 113 students. So I've now accounted for the 113th student. So that means that the 100th student is within that interval of the 62 students. So therefore, the median time spent is interval 60 to 90 minutes. And it said to justify your answer, and I've shown my little bit of maths there, which will justify it for the examiner, hopefully. Part 3, explain why the method of choosing the student for this survey could limit the validity of the conclusions. So there are a couple of reasons here for it. So if we just scroll back up here, I'll highlight a few areas that we could put down. It says here on a Monday morning. So the survey has only been carried out on one day of the particular week. So perhaps TYs are on work experience that day. So it should be more varied. They only carried out the survey on a Monday. For a more varied response, they should survey randomly across the week, Monday to Friday. So that's the first point I'm going to make. The second point we could also make is that they asked the first 200 students who came into school. Now, the first 200 students who came into school could have been on a bus who landed in early to school every day of the week. So you might only be hitting a particular student there who travels to school. So as I say, on bus, you mightn't be hitting those students who walk to school, who know exactly it takes 5 minutes to get to school, so they're leaving at a particular time just to get in on time. So that's the second point I'm going to say. Only surveyed the first 200 students in the school, which means that all possible students were not accounted for. It's not random. You might have just hit those students who come by bus. Now, you might also think there that well, what impact would travelling by bus have on coming to school and their reading? Just think about it, those 200 students who are coming by bus might be coming for a particular area, particularly primary school, where reading was encouraged by their primary school teacher. So we have to kind of think of it like that. So it's not random. Part IV, draw a graph or chart to represent the data in the table. Show clearly any relevant calculations. Label your graph or chart clearly. So in this question here, I'm going to draw a histogram because it's the question, if we go back up to the very start, is talking in minutes, which is time, which is continuous. So that's why I'm drawing a histogram rather than a bar chart. We could also draw a pie chart if you wanted to. So any graph is acceptable here. So I'm just going to go with the histogram. Just on your histogram, just make sure that the bars are touching. and that you have your scale. So on the y-axis, I'm going to put in the number of students, the frequency. On the x-axis, I'm going to put the minutes, the time. So I have my axis, I have my labels, and we could also put a title. B part 1, work out the percentage of students in the sample who are given a rate of excellent. So that is 61 students out of a total of 500 students. It wants it as a percentage, so times 100 over 1. So that's giving me 12.2%. The question didn't say to give it to a particular decimal, so it would be okay if you wanted to round down. B part 2, show that the margin of error for this sample is 4.5% correct 1 decimal place. The margin of error formula is 1 over the square root of n, and it wants it as a percentage, so I'm timesing it by 100 over 1. And the margin of error, n stands for the number of people. So I have a sample of 500 people, so that's 1 over the square root of 500 times 100 over 1. That's coming out at 4.47%. Rounded to the nearest 1 decimal place is 4.5% for my margin of error. B part 3, use your answer to part B part 1 and B part 2 to test a claim that the percentage of students in Cork who would get a rating of excellent is different to the population percentage at a 5% level of significance. So my calculations is going to be my confidence interval for the population proportion. So that's going to be my P minus my 1 over square root of n is between my P hat less than or equal to P plus my 1 over square root of n. So my P is my proportion percentage, which is my 12.2% found from part 1. I'm subtracting my margin of error from part 2, which is 4.5%. I'm looking for the population proportion. That's what the question wants us to do here, which is going to be, again, my sample, which is 12.2%, which is Cork, plus my margin of error, which is 4.5%. Tidying up both sides, I'm getting 7.7%. So my interval is 7.7% up to 16.7%. Now, the claim in the question here is that 10% of students get a rating of excellent on this statistics test. So for my conclusion, I'm going to say that there is no difference between the Cork students and the rest of the country. And my reason for this conclusion is that the 10% claim falls within my confidence interval of 7.7% to 16.7%. So 10%, the claim in the question, falls between those two intervals. Question 10a, work out the size of angle CBA. So the angle CBA is this entire angle here marked in green. So as we look at our image here, I'm going to focus in on the triangle COB for a second. It's a isosceles triangle, which means two sides are the same. So the distance from O to B and O to C are equal, which means that the angles opposite each other are also equal. So I'm going to mark those in red. So that means that this angle over here is equal to this angle here. And in order to find the size of those angles in red, I'm going to take away the 72 from 180, because all angles in a triangle add to 180, which is giving me 108. and I'm dividing that by 2 to give me the size of each of the angles. So each of the red angles are 54 degrees. So this angle here, 54 degrees. Now, each of the triangles within the shape are all of the exact same size. So that means that this angle that I'm marking here in the dark green, here, ABO is what it's called, is going to be 54 degrees as well. So therefore, the size of the angle, CBA, is going to be my 54 degrees multiplied by 2, which is 108 degrees. Part B, work out the area of the triangle AOB and hence work out the area of the pentagon. Give your answer to one decimal place. So the area of the triangle, we're going to use our formula from our log tables here. Area is equal to half AB sine C. Again, we know a lot of information here about the triangles, so I'm focusing in on AOB. So I know that this length is 6. The angle at the center here is also 72 degrees. And I can use that piece of information to find the size of that triangle AOB. So filling in my formula now, I'm going to get an area equals to half A, so that's the two sides, 6 by 6, sine of 72 degrees. Putting that in my calculator, and I'm getting an area of 17.119. So that's the area of one of the triangles. But if you look at the shape, the pentagon, it has 1, 2, 3, 4, 5 triangles. So to get the area of the pentagon, I'm going to multiply that answer by 5. So 17.119 multiplied by 5 is giving me 85.595. So filling in my areas, again, it has to be to one decimal, so 17.1, and area of pentagon, 85.6. C part 1, write down a sample space to show all of the 25 possible outcomes when the spinner is spun twice. It may be useful to draw a two-way table or to list the outcomes in a symmetrical way. So I'm going to draw them out in a table here, and I'm going to fill in my possible outcomes on the spinner. My first spinner, 1, 2, 3, 4, 5. And across the top, I'm going to write in my possible outcomes for spinner number 2. Again, they're 1, 2, 3, 4, 5 because it's the same spinner. So this is known as my two-way table, and then I'm going to fill in each of the boxes. So for instance, if I'm filling in this one, I could have the possibility of getting a 1 on the first spinner followed by a 1 on the second spinner. I could get a 1 followed by a 2, and so on and so on. The first outcome could be a 2 on the first spinner followed by a 1 on the second spinner, and again I continue on like that until I get to the 24th and 25th possible outcomes, which are going to be a 5 on the first spinner, a 4 on the second spinner, and then finally a 5 on the first and a 5 on the second. So they're the 25 possible outcomes. Part 2, what are the maximum and minimum possible totals when two numbers from the spinners are added? So the spinner is spun twice and the two numbers are added. So the maximum value could be this very last one here. It could be a 5 followed by a 5. So when we add our 5 plus 5, I'm getting a maximum value of 10. It also asks for the minimum value. The minimum value would be the very first one here. A 1 on the first spinner, a 1 on the second spinner. So that would be a 1 plus 1, which would give me a minimum 2. Part 3, each time the spinner is spun, each number 1 to 5 is equally likely. Work out the probability of getting a total of either 4 or 5 when the two numbers are added. So let's look at the totals of 4 first of all. So we could add a 3 and a 1 to make 4, a 2 and a 2 to make 4, and a 1 and a 3 to make 4. If we look at the totals then for adding to 5, we could have a 4 plus 1 to make 5, a 3 and a 2 add to make 5, a 2 and a 3 add to make 5, and finally the 1 and the 4 to make 5. So that's 3 and 4, so we have a total of 7 out of our 25 possible outcomes. So just to write in my rough work here, it's 4 possible outcomes that add to 5, and then we had 3 for adding to 4. Add them together, I get 7. So therefore, my probability is 7 out of 25, or if you want to put it as a decimal, 0.28, or as a percentage, 28%. All answers are fine. Part D. In a different spinner, there are 4 different outcomes, N, S, E, W. Is this game fair? Justify your answer. Work out the expected value of this game as part of your solution. So to calculate the expected value, we multiply the probability by the amount of money that the person wins. So the probability here for N, so let's start with the N. We have 0.3 as my probability, and I'm multiplying that by the amount that I win, which is giving me a value of 0.30. So 30 cents in other words. Coming to the S then, the probability of winning is 0.2, multiplying by that by the amount that I win. So on average, I'm winning 10 cents, 0.10 euro. The E then is 0.4, the probability of winning, and I win nothing if it lands on E. So again, the expected return there is 0.00. So no money in other words. And finally, W, which is 0.1 or 10% chance of winning, and I'd win a fiver each time. So on average, I'm winning 50 cents here. So when I add them together to get the total expected value, I'm getting 0.90 cents. So 90 cents in other words. Or sorry, I should say 0.90 euro, which is 90 cents. So the question then says, is this game fair? I'm going to say no, it's not fair. And my reason behind this is because on average, I'm winning 90 cents every time I play the game. But it costs €1 to play the game. So therefore, on average, I'm actually going to be losing 10 cents every time I play this game. So the expected value, the return I'm getting is less than how much it is to play.